Once again, you're welcome to this channel. Right, today we'll be talking about system of particles. And please, I will say, please pardon the noise at the background. All right, let's have a little discussion on what system of particles is all about. Suppose you toast a ball into the air without spinning it. The ball will fall in a simple parabolic path. And it can be treated, or it could be treated, that's the ball, as a particle. Let me give another example such that it's not a particle. Let's say a lawn tennis bat. If you toast it up, it has different parts. We have the handle, and at the point of falling, they can be changed in different parts. So when there is change in different parts of the object, it cannot be referred as a particle. So quickly, I'm going to tell us what center of mass of a particle is all about. Right, the center of mass of a system of particle is known as the point that moves as though all the system's parts were concentrated there and all external force were applied there. In summary, um, center of mass is that point in which all the force or the weight of a body acts upon. All right, so quickly let's dive into deriving the formulas that will be needed to solve questions under systems of particles. Right, let's talk about, let's start with, let's say, a particle at this point is here. Let's call it M1. And another particle is here. Let's call it M2. Definitely this will be the origin. Let's call it O. Now we want to derive formulas that will make us calculate the center of a particle, the center of a mass. Now M1 is on a Cartesian coordinates, and what I mean is we have the y-axis here, and then we have the x-axis here. It means M1 is at a position. This particle is at a position. So let's call that position x1, y1. Let's call the position of M2, let's say, is x2, y2. All right, so now let's draw a line from the origin down to M1, from the origin down to M2. Right, so let's call that line R1. Now R1 is the distance from the origin to where the first particle is, which is M1, and it's a vector quantity. I'm sorry, the distance is actually what we call displacement. I will not call it distance because distance is a scalar quantity. So I'll call it the displacement from the origin down to the first particle, and the other one I'll call it R2, which is displacement from the center of origin to M2. Now we want to calculate the center, that's from M1 to M2. There is a midpoint. Let me call that point C. So that will be the center. And if there is a midpoint there, it means it has its own coordinates too. Let me call it XCM. That is the center of the mass at point X. and then YCM. That is the center of the mass in respect to the y-axis. So I'm going to call the displacement from 0 from the origin to C. I'm going to call it the resultant. So I'm going to draw a line from here to here, and then I'm going to label it too. Right, so I'm going to call this RCM, and then it's also a vector quantity. Right, let's start. Right, the midpoint for M1 to M2, let's calculate for RCM. Now RCM equal M1, the mass of the first particle, and then the displacement from the origin, plus M2, mass of the second origin from the displacement from the origin, that's over M1 plus M2. All right, let's talk about the Cartesian coordinate system. All right, what I mean is x, y, and then let me just make mention of this. We can have the x, y, and then we can also have the z axis too. So let's dive to the xcm. That's the center of the mass at point x, right? Will be equal to M1 x1 plus M2 x2 over M1 plus M2. Now, I want us to note this M1 at the point of x is at this point. So this is x1. For M2, this is x2. Now, meanwhile, we can have more than two particles. So if we're having more than two particles, how will I write it? I'll write it like this: xcm equal m1, that is mass 1, at the position x1, plus m2, the second particle at its own position m2, plus m3 at its position at its position 3, and then so on and so forth. So we can have mn at the position n over the sum of all the masses m1 plus m2 plus m3 plus and so on and so forth till mn. I hope you're following. All right, so mathematically we can just simplify this. We can say xcm equal summation of n, I equal 1. That means the value of I changes from 1, 2, 3, 4. So I'm going to put m high xi over summation I equal 1 n mi. Let me break it a little bit. If I is 1, I'll have m1 x1 over m1. Can we see it here? And this summation sign means it's continuous. So if I was considering, let's say, two particles, I'll have m1 x1 over m1 x1 plus m2 x2 over m1 plus m2. That's what we have here. So this formula is the general formula if we're having more than two particles or more than three particles. Now, what applies to x also applies to y and also applies to z. So I will just write the same thing for the y coordinates. It's just be the summation of I equal 1 n mi yi over summation I equal 1 n, and then I'll have mi. The same thing for the, if we have third coordinates, which will be, so we have sorry for that, we have zcm. It just be the same thing, I equal 1 and then mi zi over summation of I equal 1 and mi. So these are the general formula that we'll be using in calculating. Okay, let me just chip in something. Suppose m1 m2 are equal. What will happen? Let me just try and explain that. Right, let's assume m1 and m2 are equal. m1 equal m2. Now, just imagine this, let's say a ruler or a beam or a meter rule, and then we are asked to find the center. The center, let's assume it will be around this point. This is where the center will be, xcm, right? Now, if this mass was reduced to 1, it's this meter rule, we tends to sit around the side, right? So it means that the center will shift from this midpoint to somewhere around this place. So you see how very important the mass of an object is in determining the center of that particle. I hope you're with me. So if m1 was equal to m2, then the formula will be xcm equal, let me just, this is what we have, m1 x1 plus m2 x2 over m1 plus m2. Now, if m1 was equal to m2, I will say equal to m, right? So it will be m x1 plus m x2 over m plus m equal m, I'll factorize m out, of x1 plus x2 over 2m, m cancels m, then xcm now becomes x1 plus x2 over 2. I think this looks like the mean. All right, so this does what the center of a mass of the system of a particle actually looks like. Okay, before we dive into question, let me go further and discuss about the distance from the point of origin to the mass, the distance from the point of origin to m2, and then distance from the point of origin to the center of the mass.